Today we are going to take a look at properties of logarithm. First property, log xy with the base a equals log x with the base a plus log y with the base a. Let's prove the log property number 1. Let log x with the base a equals m, and let log y with the base a equals n. Let's convert both of them back into the exponential form. So we have a to the m equals x. We have a to the n equals y. Now we multiply both equations together. So we have a to the m times a to the n equals x times y. On the left-hand side, we have two exponential forms times together share the same base. So we can simplify that. We keep the base and we add the exponent. Now we have a to the m plus n equals x times y. Finally, we want to convert this back into the log form. So we got log xy with the base a equals to the exponent m plus n. But what is m? M indeed is log x with the base a. And what is n? N is log y with the base a. So now we have the property number 1. We have the property number 1. Let's take a look at property number 1 in detail. Be sure we remember properly. We have the log of a product equals sum of the log of each factor. So when we have log ax with the base 3, we can expand this, make it becomes log 8 with the base 3 plus log x with the base 3. When we have log 7 times 3 with the base a, we can expand it, make it becomes log 7 with the base a plus log 3 with the base a. Remember the property in a proper way. Do not try to remember half of the sentence. Sometimes we would tend to think whenever we have a product, we add. That would becomes very scary. We have careless mistake like log 7 times 3 equals to log 10. We have 7 times 3 equals 10. Those are very scary mistakes. Let's see property numbers 2. Log x over y with the base a equals log x with the base a minus log y with the base a. So now we have a log of a quotient, which is equals to log of numerator minus log of denominator. So when we have log 8 over x with the base 4, that would be log 8 with the base 4 minus log x with the base 4. When we have log 7 over 2 with the base a, we can expand that, make it becomes log 7 with the base a minus log 2 with the base a. Once again, remember the whole properties in detail. Do not think of whenever we divide, we minus. That would becomes a serious mistake. Property number 3. Log x raised to the y power with the base a equals y times log x with the base a. So we have log of x raised to an exponent. That would becomes that particular exponent times log of x. So when we have log x cubed with the base 5, we can bring the exponent all the way to the front of that log, make it 3 times log x with the base 5. When we have log 8 raised to the 12th power with the base 7, we can bring the 12 all the way to the front of that log, make it 12 times log 8 with the base 7. 8 with the base 7. One more property. Property number 4. Log x with the base a equals log x with the base b divided by log a with the base b. Sometimes we refer this to change of base property. That would be very helpful whenever we need to change base. So we have log 12 with the base 4. We can turn it into log 12 over log 4. Note that on the right-hand side, we are using common log. So we change the base to 10. Or we could have log 25 with the base 3, which is equals to the natural log of 25 over the natural log of 3. Note that the base this time would be e. In summary, we have 4 properties. Note that the first 3 properties always bear the same base. So sometimes we would simply say log xy equals log x plus log y. Log x over y equals log x minus log y. And log x to the y power equals y times log x. And the last one is change of base property. We can change the base to whatever we like. Most of the time, we select the base 10, so we have a common log, or we select the base as e, so we have a natural log. E, so we have a natural log.